Hello learners, welcome to Education Online. I'm teacher Willa Lucia. So in our previous lesson, we learned about the Newton's laws of motion. But then, if you look at the second, when we were stating the second law, we talked of momentum in it, where we say the rate of change of momentum is directly proportional to the force applied. So today we shall be looking at the linear momentum. We shall have our linear So this is our subtopic for today. Linear momentum. How can we define momentum? We say that momentum is the product of mass and the velocity. So if it is the product of mass and velocity, meaning that for you to find linear momentum, you need to know the matter the object is containing, or the body, and then the velocity at which the body is moving. So we shall say our linear momentum is the product of mass and velocity. So what is the SI unit of this? Because if you're to see mathematically, we shall have our momentum, which is equals to, we are saying the product. That means that we are multiplying the mass with the velocity. So we shall have our mass times the velocity that the body is moving with, which will give us, this is m times the v. We shall have mv. So how shall we get the SI unit of this linear momentum? So if you want to get the SI unit, we know the SI unit of mass, which is kilogram, and then we know the SI unit of velocity, which is meters per second square per second, So if it is meters per second and we are multiplying these two, meaning that we are going to get the two SI units of these measurements, we multiply them, then we can get the SI unit of momentum. So since our mass is measured in kilograms, we are going to have it here as the kilogram times what? The SI unit of velocity, which is meters per second. So if you multiply kilogram and meters per second, it will give us kilogram meters per second. So this one becomes the SI unit. It becomes the SI unit of momentum. So now if we have the SI unit and we know that we have the formula, that means that it is very possible for us to calculate the momentum of a body. So let's take a look at this example. We are saying a car of mass 1000 kilogram travels with a velocity of 50 meters per second. What is the momentum of the car? So let's look at this example. Let me write it down. It says that a car of mass 1000 kilogram travels with a velocity of 50 meters per second What is the momentum? Momentum of the car. So if we have it like that, how shall we get the momentum of this car? So all we need here is the mass. Do we know the mass of the car? Because the question is telling us that the car of mass 1000 kilograms. So that is the matter the car is actually containing. So we shall have it as 1000 kilograms. To get momentum, we know it is mass times the velocity with which the car is moving. So what is our velocity here? They say it travels with velocity of 50 meters per second. So we have our velocity also, which is equals to 50 meters per second. What we need to find is the momentum. So now how do we get the momentum of this car? We say momentum is equals to mass times velocity. So this case here, our mass is 1000. So where there is mass, we shall substitute the value 1000, which we shall have it as 1000, not 50. Our mass is 1000. And then we are multiplying it by 50, which is the velocity with which the car is moving. So if we have 1000 times 50, what shall we have? So we have 1000 here. We want to multiply it by 50. So let's see. We shall multiply each term, each upper term here by this terms down. So we shall have 0 times 0, which will give us 0. 0 times 0, we shall have 0. 0 times 0 again will give us 0. Then 0 times 1, we shall have 0. Now you come to the second. You will also multiply it with this number starting from the right hand side. So we shall have it as 5 times 0. This time we don't write starting from this point, but you will come where it is located here. So we shall start writing the number under it. So we shall have 5 times 0, which will give us 0. 5 times 0 again will give us 0. 5 times 0, which will be 0. And then we have 5 times 1. And 5 times 1 will give us 5. So now we add. If you add the two, there is nothing here. 0 plus nothing will give us 0. 0 plus 0, which is 0. 0 plus 0 again will give us 0. 0 plus 0 is 0. Then nothing plus 5 will give us 5. Meaning that our momentum of this car is equivalent to 50,000. 50,000 what? Do we just leave it like that? No. We do not leave it just like that, because we have to indicate the SI unit. Here we've multiplied two measurements. So we need the SI unit, which is kilogram meters per second. So if you look at this becomes the momentum at which the body was moving with. So when you're talking about momentum, there is a situation where you see that the momentum of a body has to be conserved, which takes us to the principle of conservation of momentum. How do we conserve this momentum? Because in our previous lessons, we found out that we also conserved energy, where we said we do not waste, we cannot create or waste the energy, but we just transform it. So this time round, you see that also momentum is being conserved. So how is it conserved? So we shall have here as our principle of conservation of momentum. How we conserve momentum in a way that you see that the momentum before a collision will be equals to the momentum after collision. So the principle states that when two or more bodies collide, the total momentum before collision is equal to the total momentum after collision. So you see that the momentum with which a body started moving after them colliding, the momentum they are going to gain after colliding will be equal to this momentum they started the journey with. So let's take a look at this. Imagine you have a body here. This body was moving. It is moving with a velocity. Initial velocity the body was having is u. Let's take it as u1. But then this body has got what is known as the mass. Because if it has the mass, let's take it as our mass 1. Then as it is moving, it meets another. There is another body right here. It has got its own mass. Let's give it mass 2. This is the mass of the second body. And it's also moving with the velocity. What is the velocity that the body is moving with this time? The initial velocity, we are going to give it u2 because it is the initial velocity of the second body. So what happens when these two bodies collide? So you see that when these two bodies come here and collide, they are also going to form, there will be a momentum that they will move with. So because you can see that they are saying that the momentum is equal when it has collided with the second body. So here, after collision, what happens? It can be either moving with the velocity. It is moving with velocity v1. This is still our mass 1. This one here is now after the two bodies have collided. What kind of velocity will they move with? So at this point here, we are giving them v, which means the final velocity. So if this body here collides, if this one collides with this, what kind of velocity will it attain after that? After them meeting together. So you'll see that this one will move with a velocity v1, and then our other body here, the body 2 with a mass 2, will also have its velocity with which it is moving. So we are giving it our final velocity v2. To conserve this momentum, you see that when you add this, we know the formula of momentum. So we are going to get the momentum at this point when they are still moving separately, and then the momentum when they have knocked each other, how will they move? So you see that we shall have our m1 u1. There is another body here. We have to add it. In case we had another body also, in case there were 3, we shall add all the 3. So we shall have here as our m2. We are multiplying it by the u2 because we want to get the momentum. So this will give us equals to m1, which is the mass of the first body, times the final velocity that the body attained after them colliding, and then plus the second body. So you see that at this point here, what happens is that the bodies are still moving. So the only thing that changed is that the velocity with which the body started its motion after them colliding will change to a different value, which we are giving it as the v. So this is how we conserve momentum. So you see that when we are conserving this momentum, there is a word we've been using a lot, which is the collision. The body is colliding. What is this collision? So you see that when a body, two or more bodies come into contact with another, is what we mean by the term collision. So when these two bodies come, there is also two different ways they act. They can either stick together and move some distance with the same kind of velocity, or the two bodies will move with separate velocities. Let's have a look at this. So let's look at collision. We say that this is when two or more bodies you can either say, I'm just using a very simple term, we can say when they come together. So you see that when they come together, what happens? Because coming together is just like them being in contact. So the contact of these two bodies is what is known as the collision. So when they collide like that, what happens is that there will be two situations there. The first one will be, maybe these bodies will stick together and move with the same velocity. If they do not stick together, these two bodies might also separate after colliding. Each one takes its own direction and moves with a separate velocity. So that gives us to the types of collision. You see that there are two. We shall have the elastic collision and then the inelastic collision there. This is types of we have the elastic and the inelastic collision. So let us first look at the inelastic collision. What happens to two bodies or more bodies as they come together into contact? You see that when they come into contact under inelastic collision, they are going to under inelastic collision, they are going to be moving with the same velocity. So when they move with the same velocity, what happens? When they are moving with the same velocity, what happens? So we are going to say that for inelastic collision, two or more bodies move with the same velocity. How do they move with this same velocity? Let's take a look at body A. This body A is moving with a given velocity, which is here. We are giving it as u1. And then let's assume it is a car. When it started its journey, it didn't know that there is any other car on the road, any other stationary car on this road. But then it finds a car there. In case it is not stationary, obviously you see on the road there are cars moving. So this car comes and then finds this other car here. When it finds this car, the car was also moving in the same direction as it was moving. But then this one had its separate velocity with which it is moving. Let's give this car B. What happens when these two cars, when they crash together? When they crash together under inelastic collision, we say that they come and then they stick together. You see that? They are now embedded into each other. And when they move together, when they stick into each other, what happens? They are going to move with the same velocity. We are giving it V. But it doesn't mean that the mass of these two bodies will change. This mass A will remain with its, this body A will remain with its mass, and then the body B will remain with its mass. Let us say the mass A has, the body A has a mass of M1, and then the B has M2. This one is, again, this one will remain with its M1, the mass will not change, and then this one will remain with its M2. But then the difference here is now the velocity. So we are saying that if they are moving together, when they stick together, that means the velocity is the same. Here they are moving with the same velocity. How shall we treat that? For us to treat that, let's look at this formula. When we are looking at this, we have to conserve momentum. We say that momentum before collision is equal to the momentum after collision. So if we are conserving momentum, we should be knowing that the momentum that the bodies were moving with before them crashing into each other should be equal to the momentum they will get after crashing. So we shall have it as, from the definition of momentum, M1, which is the mass of the first car, A, and then the velocity of that car, the initial velocity that the car was moving with, which is U1. But then we are adding it because we are saying it is the total momentum. That means that each and every car that underwent the collision will have to add their momentum together to get the total momentum. So we shall have this, and then we have the second car, which is having a mass of M2, and then it is moving with a velocity of U2. So if it is moving with that and we want to conserve, what is going to be the momentum the bodies will move with after colliding? Since we say that with an elastic collision, they have to stick together and move with one velocity, that means we have to add the two masses. Because here we can see that now the mass is together, they are moving. You can see at this point here, there is no distance and they are taking the same direction. So we are going to get our mass 1. We add it with the mass 2. That means that we are now getting the momentum after them colliding. We are having the V outside because they are moving with separate velocities. If you cannot put it direct like that, we can still have it as our M1 V, then V. We are leaving it as V because you see that the momentums, the velocity with which these bodies are moving with are actually the same. So if we have it like that, we can now get the the velocity the body is moving with, because we shall get our m1 u1 plus m2 u2 is equals to, we shall have it as equals to our m1 plus m2. At this point here, we are going to factorize the common term, and in that case our common term is the velocity with which the bodies are moving with, and the velocity is given as it is the v. So we shall factorize the v outside here. So if we want to get this velocity the bodies are moving with, we can make it the subject of that formula. So we shall try to divide both sides by the coefficient of this velocity, which is the masses of the bodies. So we factorize our v outside. There we want to get the velocity with which the two bodies were moving with. So what we are going to do next is we divide through by the coefficient of this velocity, because we want to make the v the subject. So how do we divide it? We shall have our m1 u1 plus m2 u2. All of this is over m1 plus m2 equals to m1 plus m2 over m1 plus m2, and this is multiplying with a v. So you find out that this will cancel with that. So we shall have our v is equals to m1 u1 plus m2 u2 all over m1 plus m2. So you see that our m1 plus m2 comes from this, because you see that after them colliding, the two bodies actually stick together. So we have to add the two masses. By the two masses, I mean the masses of these two bodies. So when you add them together, you will divide it by the momentum of these bodies when they were moving with, before them crashing into each other. So you see that when you divide it by the mass, you're going to get the velocity with which they are moving. We only have one v here, even though in the conservation of linear momentum, we were having our m1. We had the momentum before collision for two bodies, which was looking like this, equals to m1 v1 plus m2 v2. We don't have this the v as v1 v2, because we are saying that with inelastic collision, these bodies stick together and they take the same direction. They start moving with the same velocity. If they are moving with the same velocity, there is no need for us to find the velocity of one, then the velocity of the other. So this is what we have today for linear momentum. So you should be knowing the definition of this linear momentum, the principle of conservation of linear momentum, and then types of collision. Since we've only seen the inelastic collision, we shall still continue with the elastic collision in our next lesson. So thank you very much for attending.